So I'm actually not Luke. We have a presentation of actually 3 companies here. Luke is in Europe, and as you know, there's still a travel limitation for Europeans to come to the United States, so we'll have him recorded here. So this is a joint presentation between Varroc and SiLC. So I'm from SiLC, my name is Ralf Münster, and Joel come up. Joel is from BlueSpace. So we are talking about the 2-second advantage. We've heard a lot about 2 seconds today, and we have a different way of giving you a 2-second advantage and save lives. Let's see if this works. So first we hear a short introduction from Luke, a recorded introduction, and then I'll talk about SiLC, which stands for Silicon Light Technologies, and then Joel is going to walk us through the predictive software that BlueSpace does, and we'll wrap up with Luke again at the end. So
good day, everyone. I am Luc Brisson, I'm the head of engineering at Varroc Lighting Systems. And today, together with our partners, SiLC and BlueSpace, we will present you a progress report of our ambitious project of smart headlamp contributing to improve safety, especially in the night conditions. Last spring, we already introduced the project outline, the challenges and the benefit during the DVN in Shanghai. And today, we will show a step forward by explaining how we improve the system by adding a sophisticated AI-based software. We truly believe that the combinations of advanced hardware, FMCW LiDAR technology, and AI-robust software integrated into a headlamp contribute greatly to improve safety and pave the way to a higher level of autonomous vehicles. With that, I hand over to Ralf, who will recap SiLC technology contributions, and later Joel from BlueSpace will detail the technology used for the software. Thank you.
Well, thank Luc. So let's start about SiLC. So SiLC Technologies is my company. I joined SiLC about 2 years ago. Prior to that, I was 12 years with Texas Instruments. And SiLC has been founded in 2018 and is headquartered near Los Angeles. And we have about 40 people. We have investors that are well known in the industry, like Sony, Osram, and so on. And really what we do is we integrate FMCW LiDAR on a silicon photonics chip. FMCW LiDAR is what many call the next generation of LiDAR. Today, all the LiDARs are 3D time of flight. FMCW is similar to radar, gives you velocity with every measurement. And we use this feature to give you a 2-second advantage. So the team of SiLC has over 25 years of experience in silicon photonics. This team has commercialized more silicon photonics products than probably any other team out there, with 2 prior startup successes. One was an IPO, another one was a commercial sale to Mellanox, and Mellanox is now part of NVIDIA. And we have a technology that started out in the mid-90s, and that's compared to other technologies, 10 to 100 times better in terms of performance for those sensing applications than what other competitors have access to. And we are now on our 4th generation chip, and we have developed a coherent imaging platform that offers the best performance and widest range of data, which I'm going to show in a second. So one key item for FMCW is that you get velocity with basically every measurement. Here in this point cloud movie, you see the intensity in 3D up here on the left, and then here's the same point cloud showing you the velocity image, and basically blue and green are velocities that are going away, and red and purple are velocities coming towards you. So you see details, even like the rotation of the tires and the movements. Now, FMCW doesn't only give you velocity, it also gives you precision. So here you see myself in high definition. You literally get millimeter level performance all the way out to, for example, 30 meters. And we are the only company that offers polarization. So, for example, you can get the polarization back. You can detect difference between plastic and human skin. As you can see here, I'm standing next to a mannequin. And it can give you information about is there ice on the road or what kind of the surfaces are. If there's a window or so, you can detect it. And last but not least, we also offer very long range with our solution, all the way up to 350 meters and high resolution at the same time. So with that said, I'll turn it over to Joel, and he's going to talk about what BlueSpace is doing.
All right. Nice to be back in Michigan. It's been many years since I've been here. So we're BlueSpace, and what we are working on, we're a Silicon Valley company, and we're working on the hardest parts of the AV problem that are still remaining, starting with perception and prediction. So what we offer is 4D predictive perception that works for all autonomy. And here we leverage the unique features of FMCW LiDAR that Silk was just mentioning to provide the full motion state of all objects everywhere you go. So our team is built up of AV industry veterans, both in the OEM space and AV software companies. And me personally, I actually started out my career very close to here. I worked up at the Milford Proving Grounds at GM, worked on their Super Cruise program, and after that did a startup, Drive AI, where we really pushed the deep learning-based approach to self-driving and perception, and launched services in Texas and Florida and other places. And we really got to the heart of like what worked really well and what didn't work so well. And these are the hard challenges that we're solving at BlueSpace with a brand new approach that we'll jump into. It's the green button. There we go. All right, so where are we now? Like headlights, safety, innovation, like the group here has been working on that for decades, century plus now. So we started with regular headlights, providing light so the driver can make decisions. More recently, we've put cameras in basically everything, so this again provides more information for the driver to make decisions. And in the early 2000s, we found the proliferation of 3D LiDAR that was used in a lot of AV and ADAS type applications, but these kind of suffer from cost and power and reliability issues that have prevented really mass scale adoption of these technologies, and really a lack of effective perception software to make use of this information. So with innovations from Silk, we've gotten to 4D LiDARs on a chip, which means we have low cost, low power usage, and semiconductor type scalability, so we can actually put these in mass in all our vehicles. But to bring it all together, what we're doing here with Silk and Varroc is really to integrate everything together. We have the sensor hardware from Silk, we have the perception software from BlueSpace that will work everywhere, and an overall integration into the headlight to provide a smart headlight solution that can be deployed at mass. So maybe some background is necessary, and I'll try to talk quickly so we can get to dinner faster. So what's really preventing the scalability of ADAS and AEV right now? And it really comes down to the fact that most and all AV stacks rely on millions and billions of miles of training data in order to understand what the world looks like around them and how the world is changing. Now, this really has some, I would say, gotchas that you find later on in your development program. You can do a few demos, and that's great, but this means every new geo that you go to, every new city that you launch in, you're out there collecting another 1 million miles of data. You're remapping the whole area. You need to build up an HD map. Every new vehicle model that you go to, same thing. Every new sensor that you want to use, maybe you have a cheaper one, better one, higher reliability, you're training again. So this really presents an ongoing and high development cost for your deployed AV solutions. So what we have done here at BlueSpace is provide a perception solution that requires no training data, no HD map, which means that you build it once, and you can use the same software and hardware anywhere you go and across many different models and different locations where you might want to put this. We also get to performance that wasn't really feasible before with 3D LiDAR that lets you make L3 plus level decisions. And I want to start here with improved reliability. In the case in which I mean reliability in the detection of objects and how they're moving so we can make decisions. Now, existing AV systems really struggle from the long tail. Everybody's heard about the long tail. But I'm here to tell you that the long tail isn't just about getting more and more data to cover every possible scenario. It's really a combinatorics problem. It's not just, you've seen pedestrians before, you've seen bicyclists before, but as the Uber incident that other speakers mentioned later, it's really the combination of these different things coming together that you're never going to achieve with just collecting data. You're not going to catch every possible combo of objects and colors and lighting and so on that'll cover everything. So we can't just train our way out of this. And with our generic approach to object detection, which is a motion-first approach, we have a generic way to represent all objects to provide the information necessary to make motion decisions and safety decisions. This also comes with the benefit of faster reaction time. Since, as Ralph mentioned, you get your Doppler shift with every pixel, we can take that and actually get the full motion state of the object, which includes their linear and rotational velocities, and do that in a single frame of information. So instead of waiting, if your sensor's at 10 hertz, instead of waiting for 1, 2, 3, 4 frames of data before you make a decision, that's 300 milliseconds gone, just waiting for data to come in. We can give you that information in a single frame to react immediately to sudden events. We also have the benefit of having overall reduced compute. This can work on existing automotive qualified processors. We don't need a special AI chip or GPU hardware that's going to draw down your power and reduce your electric vehicle's overall range. Next part is commercialization. One of the key things that's really limiting wide-scale commercialization of this technology is there's no real good way to certify existing AV systems. They have millions of miles of data. Who's looking at that? Who's validating that all your annotations and labels are correct? Here we have a closed form solution, so we can actually go through the usual ISO 26262 V model, certify every part of it, and then have it actually inspected by a third party, and maybe even a regulatory agency. This is a capital and time efficient approach since we're not collecting tons of data and mapping new locations, which means you can deploy in any new market that you want to go to without an ongoing or new development cost each time. And this is a new thing, really, that our people are getting worked up about or concerned about, rightly so, more recently, is data privacy. If all these cars are going around there collecting tons of camera data all the time, and sending it up to the servers, there are some serious data privacy concerns that we need to get into, and we avoid that by not requiring any data. We don't need to collect it, which means there's no privacy concerns, which means you can deploy in Europe with their additional data privacy regulations coming out. You can deploy in China without the government getting mad at you, and you can just do it. So anyway, enough talking. How do we actually work on public roads? So here you'll be seeing a couple videos where we're seeing data from SiLC sensor and our software processing it. You'll see the LiDAR and our perception outputs on the right side of the screen. You'll see the current position of objects in dark blue and the future positions of those objects based on the motion perception in light blue. And I want to highlight that all these objects are treated generically. We don't need to categorize them. You get velocity, a linear and rotational velocity in a single frame. And we are providing a camera overlay, but that's just for us as the audience to know what's going on. And again, this is the first time we were driving around in San Jose. No HD maps, no training data. This works there, and it'll work just as well in Michigan. So here we are. We're driving up behind this bus here, and the bus we're detecting and classifying its motion, measuring its motion. And here there's no bounding boxes involved. There's no categorization of the bus. It doesn't matter that it's a bus. We're measuring all these objects as we drive here. The next, you'll see this car that's kind of cutting out across our field of view. Here you can notice the linear and rotational velocities that are measured of that car. And here we're handling 3 small mopeds, I think, not quite motorcycles. But again, driving at night, they're hard to see, they're weaving in and out, but we're able to both detect them and give you their full motion states for making future plans that additional ADAS systems can react to. So there's a bunch of them. They're still weaving around. So we can skip ahead to the next thing. It's not just cars and other normal objects that you see. There's also vulnerable road users that we're all very concerned about here, and many of the speakers highlighted bicyclists as a challenging thing. So here we'll have a bicyclist just suddenly cut out onto the road, and instantaneously, the first time it's in the sensor's field of view, we have its motion and where it's going. And as the bicyclist is zigzagging across the street, we're able to see that the perception software is able to detect not only that they're there, but they have this zigzag motion. This is another bicyclist example here in San Jose, where this bicyclist will cut right into the road and cut across all the lanes just because they felt like it. But these are the types of situations that we need that 2-second advantage to be able to detect their motion instantly, so our downstream control functions can have the time to react and make safe decisions to keep vulnerable road users and pedestrians safe as well. So this is a scalable solution we see for L3 commercialization. We call this perception without boundaries because it will work any place, any object, any vehicle. If you have a test vehicle that you want to try it on, we can try it. We don't need to collect any data from you. We don't need to go through an extensive development process. You can just get it going. So immediately deploy, if you want, I'll be here to talk right after. But if you're listening in from remotely, feel free to reach out at partners at BlueSpace. And here I'll hand it back to Luke to wrap up.
Thanks, Ralph and Joel, for your presentations. As a conclusion and next step, we are convinced that with the work already achieved, we are on track to demonstrate this superior technology into a vehicle. And we look forward to seeing you in Q1 next year to demo a ride. Thank you and have a good day. Bye.
So thank you all. So we are around here. If you want to contact us, you can also contact us via our email addresses. So thanks.
Thank you.